Hello. I just watched a video by Blue Marble Science who responded to some videos from some flat earther about why we should feel acceleration going around the sun because of the speeds involved. And I thought I was going to try it myself. Now, the thing is, you do not feel speed, you feel acceleration. And if you want proof of that, go and get yourself a bus ticket and go and ride the city bus. You'll notice that the only time that you're going to want to smack on the floor if you're not holding on to something is when the driver presses the brakes. So the greater the acceleration or the deceleration, which is a rate of change of velocity with time, then the more force that you feel. But as long as the bus is going the same speed down the road, you're not going to feel like you're going to want to fall on the floor. So let's take a quick look at the problem. So the Earth is rotating on its axis, and it doesn't matter where the Earth is, it doesn't matter where you are on the Earth, you are going to have a velocity in some direction. When you're standing over here, your velocity is going to be in this direction. When you're over here, your velocity is in this direction. And when you're over here, in this direction. When we add a vector, which is the Earth orbiting around the sun, we add the vector in this direction, we don't add the vector in this direction. So when you're over here, your entire velocity is in this direction, represented by this blue line. The gray line represents your velocity regardless of your direction. And when you're over here, you've got some vector in this direction and some vector in this direction. And similar over here, your entire vector is in this direction. And as you can see, it's the same thing going all the way around. When we go in this direction, we're adding this vector to this vector. And then obviously when we start coming around, we subtract this vector from this vector. So let's take a look at the spreadsheet I created. So the Earth radius is 6,371 kilometers. I calculated the circumference at the equator, and the equator speed is 1,667.9239 kilometers per hour, and the speed around the sun is 107,000 kilometers per hour. Next, what I did was I took 24 hours from 00 to 23:59:45 in 15-second increments. I converted that to seconds in a 24-hour period. The perpendicular vector, which is this one, is going to be 360 degrees times this divided by 86,400, converted to radians. And I take the cosine of that and I multiply that by the speed at the equator. My kilometer per hour delta is going to be this value minus this value. And for the case of the first one, I go and I subtract the last one down over here. For my parallel speed, which is in this direction, I add to the speed going around the sun the sine of this, which is a very similar equation to this one. The only difference between these two is that this is cosine, this is sine, and for this one, I add my speed around the sun. Kilometers per hour delta parallel is this minus this. So now I have a difference in kilometers per hour. I recomputed this value with this equation, and I did something similar for the two kilometer per hour deltas to give me a combined delta. But because these are in 15-second increments, I divided the result by 15. Let's see what happens if we change the speed around the sun. The only column that changes is this speed here. Everything else remains the same. I can put whatever I want. I can go around the sun clockwise. I can go around the sun counterclockwise, and all of these values, except if I get these numbers too big, all of these numbers remain the same. So what can we see from this? When I was analyzing this, the biggest surprise I had was that the change of speed seemed to be the most from this point to here, and that the rate of change of speed where you would expect to see the biggest change turned out to be the smallest, like that. But keep in mind that this is a change in kilometers per hour in 15-second increments. So there you have it. By my calculations, I just added this extra column. This is the change in rate in kilometers per hour parallel to the Earth's rotation divided by 15. And it ranges anywhere between 0.121294828 kilometers per hour per second to essentially something closer to 0. So hopefully this was interesting. That's it for now, and hopefully I'll see you again in another video soon enough. Bye for now.